So we're working now in chapter 6, okay? Let's just see some. We're working now in chapter 6, okay? Here, we're going to basically, how do I say this? We're going to continue, I guess, our exploration of mathematics in finance, so to say. You know, in the previous section, we saw simple interest, we saw compound interest, we saw the APY, which I think stood for annual percentage yield. But now we're going to look at these, which are annuities. And in particular, we're going to look at payout annuities. Actually, excuse me, payout annuities and savings annuities. That's what we're going to look at. And we're also going to consider loans. You know, we are going to see that. And compounded, and yeah, we're going to see those. Now, I don't know what kind of calculator you guys have, but if you do happen to have a TI-84 graphing, that's, I guess, good, because you don't need to buy one, because what happens in the book, there's something called the TVM solver. I think it stands for time, value, and money. But I think those kind of calculators or later ones have that built into it. But you don't have to buy one, because there is an online free version of that TVM solver through GeoGebra. So I will show that to you guys today. I mean, I did buy an app. It was only $6 that makes my iPhone into a TI-83 calculator, so to say. It also works with my iPad as well. So, I mean, you don't have to buy a graphing calculator, okay? You know, I know they're at least $100, and I don't want you guys to have to buy it, because I don't think you'll be using it otherwise. So at least in this class, you won't need to use it. That's what I meant to say. So, okay. But anyway, let's get started with chapter 6. So this is going to be a little bit different than chapter 5. I mean, it does build on finance, but with a savings annuity, what's going to happen is from each of our paychecks, the idea with the savings annuity is it's a special kind of account that you make monthly deposits into. You know, for instance, maybe you're working, and from each paycheck, a certain amount comes out and goes into that account, that savings annuity. You know, it's just a type of account. For instance, they have retirement accounts. That's one example. I'm sure there are other examples, but the only one I could think of when writing up these notes was retirement account. You know, if you're working, you want to save up for retirement. So a certain percentage or a certain amount from your paycheck, say, I don't know, $100, let's say, would go automatically into that account. And it would sit there, and the money there would earn interest. You know, the account could be compounded, I don't know, monthly, let's say, or even yearly. So you can see this is actually going to build on what we did in chapter 5. With compound interest from the previous chapter, you know, we would consider putting money into an account, leaving it there, not making any other deposits or withdrawals, and the money would build interest on its own, so to say, by compounding. So here we're going to build on that a little bit. Excuse me. But we are going to make some assumptions. For instance, as you can see here, we are going to assume that, oh, sorry, not yet. We're going to assume that we're putting equal amounts of money into the account on a regular schedule, okay? So we're going to assume that we're putting equal amounts of money into the account on a regular schedule. You know, like, so for instance, maybe, you know, every month we're going to put in $100. I mean, normally, or realistically, I should say, that doesn't have to be the case. Maybe you make more money doing some other side jobs, let's say, during the summer. So you might put more money into the account then. Or maybe during winter, you try to spend less for whatever reason by not going out as much. And so then you decide to put less money in there. I don't know. But here we're assuming that we're going to put equal amounts of money into the account, the savings annuity, on a regular schedule. And again, it's going to sit there earning interest. And something else we're going to assume is, generally what's going to be the case is the number of compounding periods will be the same as how many deposits we're making. It will be the same frequency, in other words. So for instance, if we're making monthly deposits, then we're going to assume the account is being compounded monthly. Or if we're making a deposit every day, for somehow we're able to do that, then it would be compounded daily, that kind of thing. And all this stuff occurs at the end of the month. I think that has to do with the TVM solver that's in the TI-83. The book references it. I think that's the reason why they're saying at the end of the month. I'm not too sure, honestly, but we're just going to assume that, though. It might make the calculation easier, but that's what we're going to assume, that the deposit and the compounding that occurs is all at the end of the month, at the end. Okay. Let's do some calculations to see how this works. Then we'll get to some nice formulas. So for instance, let's suppose, we're working and we're going to make monthly deposits of $100, let's say, a month into an account, a savings annuity. Now, the account is earning 12% annual interest. Now, that's annual interest, though. But since we're making monthly deposits, we're also going to assume the amount is being deposited monthly. Excuse me. No, oh boy. So we're assuming that the account is also being compounded monthly. That's what I meant to say. I'm sorry. So deposits are being made monthly, and the account is being compounded monthly. Okay. Sorry, my brain just went in different directions for a second. But anyway, that is what we're assuming. But notice also that since the annual interest, the APR, is 12%, each month the compounding occurs at an interest rate of 1%. You'll see from the table what I mean by that, but basically what's going to happen is each month 1% of the amount in there gets added on. Not 12%, 1% every month. The 12% is for the whole year. Okay. So for instance, this is month 1, right? There's nothing in the account yet. We just started working. We just opened the account. So since there's nothing in there, no interest is built on yet. No interest is added yet. We make our monthly payment of $100. By doing so, we're going to have at the end of the month $100. Good. Now, then comes into month 2. Now, so the balance was from the last month, which is $100. Interest is built on that, right? 1%. Well, 1% of 100 is $1. So $1 is added on to that. We make our next monthly payment of $100, and then we end up with $201 at the end of the month. That's our ending balance. Next, we have $201, okay? That's our prior balance. That's from the previous month, okay? So again, we're going to get 1% of that from interest, which is $2.01. We make our monthly deposit payment of $100. We add these three together, right? That's going to be our new balance, which is $303.01. Essentially, we have from what was last month, we add the interest and we add the monthly payment. That's why we get this. And this keeps on going. So for month 4, we have the prior balance. We're going to get the interest, which is 1%. And then we add our monthly deposit, our monthly payment, that is, and that brings the balance up to this. So it keeps on going, for how many months this is happening. It could be a lot, because we can do this for years. So, but really that's illustrating the idea Notice also in particular that the interest is increasing, the interest we're earning. That's kind of expected because, the balance is going up. I mean, even if we weren't making monthly payments, although we would have to start with some amount, the interest would still increase because the balance is going up. Okay. Our monthly payments are the same though. Now, what's really happening in the long run is given by this formula. So this formula is basically telling us what's happening in the long run. Namely, that will tell us how much we'll have in that account down the road, some time down the road. Capital A is our balance, the balance after T years. PMT stands for the monthly deposit. Okay. The R, that's our APR, but you write it as a decimal. N is how many compounding periods are made in a year. So for us, if we're doing monthly deposits, then N is 12. If we're doing annual payments, that is annual deposits, then N is 12. Again, we're assuming what I have over here, compounding frequency is the same as the frequency of how many deposits there are in a year. T is how many years this goes on. So this is our formula. I did send out the notes just now, so this is in there. It's also in the book, of course. Okay. So what we're going to do shortly is we're going to do some examples with this. Let me just stop the recording because I don't want to put too long. I don't want to record too long at once. Okay. So.